Hi guys, welcome back. We have been learning really hard about how to solve different types of word problems. We've learned several different strategies and used different models to show our thinking. Today, we are going to learn about another type of word problem. Let's go ahead and look at our learning target. Our learning target today is I can solve word problems with unknowns by using a model and an equation. Now, we've learned along the way that when we have an unknown in the problem, we put a box around it. That way, we know that is what we're looking for. As we are solving these problems, make sure that you have an equation and a model. Before you get started, I want you to make sure that you have all of your materials ready. You will need a pencil and paper or a marker and board. If you are using manipulatives, you may want to use your cubes or counters as well. Go ahead and gather everything you need, and when you're ready, hit play. All right, guys, are you ready to get started? I hope so. Let's go ahead and look at our first type of word problem today. On my board, I have this problem. There are some butterflies on a flower. 3 more butterflies join them. Now there are 11 butterflies. How many butterflies were there to begin with? So let's think about what this problem is saying. Let's look for some clues about things that we know and what we need to find out. There are some butterflies on the flower. Do I know how many butterflies are on the flower? No. It said that there are some butterflies on the flower. So I know that this is my unknown, and I am going to put a box around that word some because I don't know how many I'm starting with. There are some butterflies on a flower. 3 more butterflies join them. So I know that there were 3 more. What does that tell you you're going to do? If there were some on the flower and 3 more came, what do you think that we'll be doing? That's right. We're going to be adding 3 more. It says now there are 11 butterflies. Now there are 11. So let's think about what this is saying. There were some butterflies, 3 more came, and now there are 11. What type of equation would you write to help you solve this? Take a minute and write an equation that would go with this problem. Great thinking, mathematicians. So if we're writing this problem, let's think about what it's saying. It said that there were some butterflies. So I'm going to put me a box because I don't know how many butterflies there were. I know that 3 more came. So I'm going to put plus 3, and now there are 11. So equals 11. Something plus 3 equals 11. So knowing what I know about my problem and how their numbers work together, I know since this is now there are 11, this must be my whole. And the 2 numbers that I'm adding together are my parts. So I have a part plus another part equals 11. So let's think about how we would solve this problem. I could use a part whole, which I saw a lot of you use. What is our whole? There are 11. What is the part that you know? 3. And we need to figure out what our missing part is, how many we started with. So we know a part plus 3 equals 11. We also know that 3 plus our other part will equal 11. So how would I solve that? If I have 3, I can count on until I get to 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many butterflies did we start with? That's right. We started with 8. 8 plus 3 equals 11. 3 plus 8 equals 11. Another way that I saw someone do that was they started with, they knew they had 11 counters. So they know they weren't going to have more than 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They know that the 3 came. So they went ahead and separated 3. So how many did they start with? They started with 1, 2, 3, 4, 5, 6, 7, 8. If you have 11 and you take away the 3 that you had, then you have 8 left over. So I know that 11 minus the 3 equals 8. Or I could say 11 minus 8 equals 3. Another way that you could have used this is with a number line. And when we're writing our number line, be very careful not to skip any of your numbers, because that can lead to a misconception when you're solving. So I don't know where to start because that's a sum. I do know how I ended, which was 11. So I'm going to start at my 11. And I'm going to take away the 3. 1, 2, 3. And that leaves me with 8. 11 minus 3 equals 8. Because we know that we can use our part or our whole, take away a part to get our other part. Great job, mathematicians. So this means that there were 8 butterflies to start with. Let's look at another. For this problem, it says there are some ducks in the pond. 6 ducks join them. Now there are 12 ducks. How many ducks were in the pond to begin with? Let's think through our problem. There were some ducks in the pond. Do I know how many ducks were in the pond? No. So I am going to put me a box. 6 ducks joined them. So there were some, and then 6 came. So what does that tell you that you need to do here if 6 ducks join them? That's right. You're going to be adding 6. You had some, 6 ducks joined them. Now there are 12 ducks. What equation would you write to help you solve this problem? When you have your equation written, go ahead and use your strategy or model to solve this problem. When you're ready, hit play. Great job, mathematicians. So if you're writing out your problem, I don't know how many I started with, so I'm going to have a box. I know that 6 ducks joined them, so I'm going to add 6. And now there are 12. Something plus 6 equals 12. Let's think about how our numbers work and how we could do that. I know a part plus a part equals our whole. I also know that a whole minus a part equals our other part. You can think backwards to find the beginning. Something plus 6 equals 12, then 12 minus 6 equals that something. Let's see how you solve this problem. I saw some think about their part-whole relationship. I saw some use a part-whole. We know our whole is 12. We know our first part is 6. What we need to know is our other part. We can put our parts together. 6 plus something equals 12. Let's see how that would work. Let's count on. 6, 7, 8, 9, 10, 11, 12. So how many would be in our other part? That's right, it would be 6. Because 6 plus 6 equals 12. And I could fill it in up here. 6 plus 6 equals 12. So that means that 12 minus 6 also equals 6. Is there another model we could use? Great thinking. We could draw out our 12 I could minus the 6 that I know, and that leaves me with 6 left. 12 minus 6 equals 6. Great thinking, mathematicians. As always, you can also show your thinking on a number line. I would start at 6, or I start at 12. I would minus the part that I know, which is 6. 1, 2, 3, 4, 5, 6. And that leaves me with 6. So when you have these type of problems, think about your symbol for your sum. Think about what's happening. Are we adding or subtracting? And then what are we ending up with? In this case, we had sum plus 6 equals 12. You can think backwards. 12 minus 6 equals our something. Your whole can minus the part to get the other part. Great job, mathematicians. Let's try another one. In this problem, it says Alicia had some toy cars. She got 8 more toy cars for her birthday. Now she has 15 toy cars. How many toy cars did she have to begin with? Take a minute, look at the problem, and think about what you know. When you're ready, hit play. I heard some great thinking. Let's think about what we know so we can label our problem. Alicia had some toy cars. Do we know how many she had? No, so I know that's where my box is going to be. She got 8 more toy cars. So what does that mean? That's right, that we're going to add 8 because it said she had 8 more. Now she has 15. So let's think through what our equation would look like. She had some. She added 8 more, and now she has 15. Go ahead and write your equation on your paper or your board, and when you're ready, hit play. Great thinking, guys. So I start with my sum. I add my 8 more, and now I have 15. So, I know I can only add my 2 parts together. So I know this is a part, this is a part, so this must be my whole. When I'm solving these types of problems, when you don't know how many are to start with, you may want to look at your fact families to try and flip the equation around to make it easier. So if something plus 8 equals 15, then 15 minus 8 equals something. So it's sort of like you're working backwards through the problem. Something plus 8 equals 15, then 15 minus 8 equals something. You can also think about it this way. If something plus 8 equals 15, then 8 plus something equals 15. Let's go ahead and try to solve some of these equations. On your paper or your board, what model or strategy are you going to use to help you solve? Go ahead and try, hit pause, and when you're ready, hit play. Great job, mathematicians. I saw a lot of great thinking. I saw someone use this equation to help them solve. They started with 8, and they counted on until they were at 15. Let's do that together. 8, 9, 10, 11, 12, 13, 14, 15. How many did they have to add to get to 15? Let's see. 1, 2, 3, 4, 5, 6, 7. So 8 plus 7 equals 15. If 8 plus 7 equals 15, then 7 plus 8 equals 15. I saw someone use this equation to help them solve. They had 15 counters. They minused 8. And that left them with 7 left over because 15 minus 8 equals 7. Great thinking, guys. You could also show this type of problem using your number line or a part whole. Use whatever strategy you think you're more comfortable with. As we solve these types of problems, always think about what we know and what we need to find out. These problems that start with an unknown, try to think backwards. If something plus something equals 15, then 15 minus something equals something. You're thinking about your beginning. I want to address a misconception that I did see happen. Remember, a misconception is a wrong way of thinking about a problem. Someone had 15 plus 8. Take a minute to think, why would 15 plus 8 be a misconception for this problem? Take a minute, hit pause, talk to a partner, and when you're ready, hit play. That's right, guys. I know that I ended with 15 because it said now she has 15. It did not say she had 15 and got 8 more. So I would not add the 8 and the 15 together because 15 is our whole, 8 is our part, and we're trying to find the other part. Do we ever add our whole to a part? No, we never add a whole to a part. So this was a misconception. Think deeply about the problem and what it's asking so that you don't have those misconceptions when you're trying to solve. Great job today, guys, with solving the beginning of the problem. We were solving start unknowns. So we had an unknown in our problem and had to think about how to work backwards to figure what that number is. You guys did a great job of using models and equations to solve for unknowns. Keep practicing, and I'll see you next time.